Okay, so we're going on to page 32 and section 2.4. Okay, so we're continuing to work on flexibly converting between factorized and expanded forms of algebraic expressions. Okay, and in particular we're going to be looking at x squared plus bx plus c, so monic where it starts with a 1, and then a more general trinomial where a, b and c are integers, where there could be a number in front of x squared. Okay, so they actually lead off here with a really slightly difficult example. So just before we get to that, we're going to check what we know in terms of, we want to be able to expand and factorize. They're opposites. So let's do some expansions using the FOIL method. Okay, and we get x squared, and this is not about FOIL, okay, this is not about expansions, that's a different chapter. I think it's chapter 1. So we're going to be able to go from this to this. That's what this chapter is about. Okay, and we're going to see what happens when we have a positive and a negative. So we would end up with x squared plus 5x minus 14. And the big thing we're going to find there is if it ends with a minus, there's going to be a positive and a negative factor. Okay, we're going to see what happens if it's x plus 1 multiplied by something else like 5x plus 2, and so on. We're going to look at all sorts of cases, but okay, so enough said there. We're going to jump in. We look at the method they use in the book, and we look at the big X method. Okay, so let's just jump straight in. So when you get 3x squared plus 10x plus 8, we know that our two-way table will have a 3x squared here and an 8 here. Okay, so we're trying to find out what are the factors that go here and here. Okay, so one thing we know for sure is this must be a multiple of 3. Okay, because you have to be able to take 3 out, and so we want to write 10x with a multiple of 3. So basically, I mean, one way to think of it is to go back to the previous section, the grouping section. So we're partitioning this, and it's kind of obvious once you've done it a few times. We're partitioning this like this. Okay, so then we could have gone straight into factorizing it. But what they had to do here is, you see, again, it doesn't matter whether you come down the way or. So I'm going to put a 6x here and a 4x here. So 3 is common, 3x is common actually, and only an x is common here. Okay, what's common here? What's the highest common factor down the way? It's 4. And what's the highest common factor? And indeed, what would I have to put here? You'd have to put 2 here to get 6x. So it's kind of, I wouldn't be a fan. Okay, but you end up with the same as they've got here, x and 2 and 3x and 4. Okay, so another method, much easier, is to go with a big X or a big frame and say I'm going to put my x terms at the beginning, and there's only one way that can happen because that's a prime number. Okay, and I'm going to put 2 numbers here that multiply to 8. Okay, now in time we're going to learn that if the middle isn't 3 and 8 11, and it isn't 3 8s 24 and 1, then there's no way the 8 can stay as 8, so it has to be 4 and 2. Now I'll do some trial and error. 4x is one of our cross products and 6x is the other, so I've stumbled upon it straight away there. Okay, so you split this up into 4 and 2. It's a plus plus, so you put your signs there. and you have 3x plus 4x plus 2. Now you might say, well, why would we bother factorizing when if we're solving it equal to naught we can use a thing called a minus b formula? And the reason is all about this variation is much faster, and it's important to understand factoring in order to understand the bigger maths in a better way. Okay, so it's important to understand factoring. Okay, so we're going to do the next example, example 2, which is 2x squared minus 11x plus 12. So this is a prime number, this is a composite number, so the prime number is really easy. Okay, the other number, just want to say that this is odd, so there's no way I can use 6 and 2, because then I would be getting two even cross products. What we're going to do is we're going to put our cross products here as we stumble with them. Now the other thing is this is going to be a minus minus, because there's no way to end up with plus on the end and minus in the middle, except it's a minus minus. So we got to understand that, and understand the name of the game is adding up our cross products. Okay, so let's do trial and error. Like I said, I can't use even, so I got to have an odd number and an even number. I can't put 4 there either, because if I put a 4 there, then this entire factor would have been even, and then everything here would have been even. So there's no way it's a 4 here, so that means it has to be a 3 here and a 4 here. Okay, let's see how we're doing. This is multiplication, it's minus 3x, and this is multiplication, it's minus 8x, and this is our confirmation that we're on the right track. Now we could have kind of left out the minuses there and just put them in here, because when you add negative numbers, two negative numbers, they embellish each other. Okay, they don't diminish each other, which is what you get when you get subtraction. So it's still adding, it's just adding and keeping the sign. So whether we put the signs here or not is really a matter for debate, because we're going to put them here anyway. So that's the answer there, 2x minus 3 and x minus 4. So there's lots of kind of important ideas that makes it that you don't have to do a lot of trial and error in these. I'll do example 3. With the final term negative, it will be a plus and a negative. So we'll go with 8x squared plus 10x minus 3. So the one thing is for sure, it's going to be 3 and 1. It's going to be a plus and minus, but we'll hold back on that until the end. You'll see why now in a second. And the middle is even, so I'll definitely be using these two evens here, 4x and 2x. Why am I going 4x and 2x? Well, this has to be an x term and an x term, and the two numbers have to multiply to 8. This is even, and there's very little other ways except even, unless it was 8x and 1x. That wouldn't be allowed because I'd end up with an odd there. Okay, I still could be upside down, and one will be positive and one will be negative. So what we're going to do here is we're going to subtract. So it's trial and error now. I mightn't be right yet because this could swap, but at the moment I have 6x worth and I have 4x worth, and that's no good because they don't subtract, they subtract to 2x. So I've got my 1 and my 3 upside down. Now there's no point in swapping them as well, because you see it's the same thing to swap these as to swap these, so there's only one swap necessary. Okay, so now I have 2x up here and 12x here. Now it doesn't matter what way you subtract, well it does, but right now I'm just saying, do they subtract to 10x? They do. Now the next thing is I look at this sign and say it's positive, so that tells me one of these is positive and one of them is negative. So that tells me the big one has to be positive, the small one has to be negative, and then you can follow that minus in here, and if you want, follow that plus in here, because it's one plus and one minus. So that's how that works. And you get 4x minus 1, 2x plus 3. Now loads of students find this very, very difficult, but with some practice you can do it. Okay, especially with the fact that there aren't that many things to check with. So double check we got that one right, and of course we did. 2x plus 3 and 4x minus 1. Okay. Oh, there's another one here. Lovely. Okay, so starting off with a prime number, 7x squared minus 19x minus 6. Okay, so big frame, so there's a minus here, so we're going to be subtracting down here to get 19. So we're going to need something bigger than 19. 3 I would imagine, and 2 might be where we want to go here, because that'll be 21x, and that'll be 2x, and we have it already. We have it already, but that minus goes there, so this is minus and this is plus. 7x plus 2 x minus 3 equals, and then it equals 0 if you're solving, but that's the answer to that. Great. And the great thing about the frame is it works for all trinomials, okay, except unless it doesn't. What I mean by that is, if they say in the question solve it equal to, if they said solve x squared, I'll give you an example of one, minus 3x minus 19 equals 0, and they said solve to 2 decimal places. Well, that's the dead giveaway for the fact that you won't get a fraction in your answer, and you won't get a fraction in your answer because it won't factorize. Okay, but we don't have to worry about that now. You can assume that everything here factorizes. So I'll work my way down the right hand side. It's going to be fast, and that's why you have the pause button. We're already 11 minutes in, so you can pause now, take a break if you want to, and then I'm going to do these at full speed, okay, because you have a pause button. So, and I will just say one other thing. If they start with x squared, you could say I won't bother using the frame, but the frame works every single time, so I think you should start using the frame, and then maybe later on you might stop using it and say, sure, I know here I'm trying to get two numbers that multiply to 14 and add to 9, 7 and 2. So you could just say, sure, I know the answer is x plus 2 and x plus 7. But to begin with, we really want to be going through the motions here. So how do we get x squared? It's x and x. How do we get 14? It's going to be 7 and 2 to get 14, and then 7 and 2 is 9. You see, so you got your 7x and 2x. You've got your plus 9x. They're both plus, and then have that one done. Okay. Question 6. Now I can say the two numbers add to 12, or I can say the two numbers multiply to 27. Either way, in this case, here is where my two numbers go, and it's 9 and 3. Okay, 27 equals 3 by 3 by 3, which is 9 by 3. Okay, so x plus 9 by x plus 3. Next one, x squared plus 20x plus 36. The two numbers have to add to 20, and they have to multiply to 36. Now that's a challenging one. What we can do is we can factorize 36, which will be 2 squared, 3 squared. And then we're trying to get, so it could be 2 times 18, there it is. 2 and 18 are the numbers. Okay, so it would be, and if you figured it out for these simple ones, if you figured it out without going to the frame, you figured it out without going to the frame, and that's your answer. Okay, but now with the 5 here and the 4 here, we're definitely going to the frame. Or the two-way table from the previous page, but it's the same thing. It's just that this frame is far better established. You'll find far more content. It's the same. It's hardly a variety at all, but it just looks better. Now, one of the things you can study is special cases. So there's two special cases that so I can straight away see a trick here. 5 4s is 20 plus 1 is 21. So I know that 4 doesn't split. I know straight away from experience that when I do this, I want the 5 and the 4 opposite each other. Okay, and I want x and 1. These are this is a unit entry for x, and this is a unit entry for number. Okay, and the way to see how that works is actually to start to multiply them out. Say, what if we have a 1? So if we do sums like this and multiply them out using FOIL, and say, okay, you can put anything you want here. Let's do plus plus for now. And you can put anything you want here. Let's put 10 there. Okay, then you're going to get 1x and 70x. And what you can notice about the 71x is it's 1 bigger than 7 tens. So the minute you see this bigger than 1 bigger than the outsides multiplied together, you know you're putting the 5 and the 4 on a diagonal. So, and there's little variation on that. If it's a minus at the end, it'll be subtraction, but tiny variation. And if it's a minus in the middle, they'll both be minus. Now, the only other special case, or another special case, would be, well, what if you had 7x and 2 times x plus 1? So what are the properties of multiplying by x plus 1? Well, then you get a 2x and a 7x, so the middle looks like the sum of them. And sure enough, we'll find it down, hopefully, if 8 and 3, no. 12 and 10, no. And of course, this author didn't put in any. We probably have some this way. So this is, I'm beginning to get it sound a little bit confusing. Oh, annoying, annoying. This is where, if I was writing my own book, I'd design it slightly different so that you'd have you'd actually be able to see all the cases. But I can make one of them up for you. I mean, it's very, very easy. Start with a prime number, end with, it doesn't have to be a prime number, but it makes it easy. And 5 and 11 is 16x. So if you were doing this, so you'd say, well, I know, so then you would know, well, the 5x, and you don't have to, you would figure it out anyway. The 5x and the 11 stay on the top, and the x and the 1 go on the bottom, because you have 5 and 11 is 16. Okay? So as we get on to different questions further on, we'll do them like this. Now I'll try and stick to the book a bit as much as possible now. So x squared minus 9x plus 20. So my frame will have two negatives. Okay, so if it's minus here and plus here, my frame will have two negatives. It's x squared, so it's just x and x. And I'm looking for two numbers that multiply to 20 and that add to 9. 5 and 4. Now yes, you have to dress that up like this, but I'm going to, once I'm finished on the frame, I'm going to leave it that the frame is the answer as we go down along, just for the sake of speed. X, 9 and 4 will do us here, minus and minus. Number 21. It's a prime number, and it ends with a composite number. And the middle is not 31 and it's not 11, so I know I'm splitting this, which leaves me one choice. Is it 3, 2 or is it 2, 3? 3 and 10 is not okay, so I didn't even write them down here. I checked them in my head, so I'll swap them. And 2x and 15x is okay. They're both negative and these are both negative. So 5x minus 2. So see, there's a challenging one there that the frame came in really handy for. Okay, that one. Now I'm hoping I know I'm going very fast. You're pausing and you're working that question over and over again until you're confident. Okay, 3x squared minus 14x plus 15. Big frame with a 3x and an x. I need 5 and 3. If I put 5 here, it'll be too big, 15, because they're added. So 3 here and 5 here. Now, you can say straight away they're both negative. We'll be getting onto ones with, they've all had plus at the end of them. When we get onto some of the minus ones down further. So like I said, you know, there's a 9x and a 5x adding to 14x, and you can put a tick here to say I know I'm right now, and then you can go minus, 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 minus. Okay, a negative one coming up. but at least it's monic, meaning it starts with x squared, so it won't be too bad. Okay, x squared plus 7x minus 18. So the numbers will be 7 apart, by the way, because there's a 1 here. The numbers will be 7 apart. So two numbers, 7 with a difference of 7 and a product of 18. 9 and 2. This is positive, so this is positive. This is negative. Okay, number 30. X squared minus 18x minus 40. The numbers will be 18 apart. They're very, very big and small, 20 and 2. Okay. We'll be getting 20x and 2x, and we want the difference when we add these, we want to get minus 18x. So this is the big one, the sign of the big one. $33. Okay, I'm going to split the 8 because 3 is prime, and because 25 is not there and 11 is not there. Okay, so let's split it. 4x and 2x. It's hit and miss now. It might be right, it might be wrong. I have 6x and 4x ain't working out for me. So let's try the other way. Now some people mightn't even write it down, they just do it in their head so that they don't have to cross anything out. But now we're looking good with the 12x and the 2x, and it's plus, so we're adding them to get 14x. It's just that they're both negative because of this. And we have 4x minus 1 by 2x minus 3. 1, 2, 3, 4, 5 to go, and then we stop the video, and you'll have to, this is a very, very difficult video, I know it, but it's very important as well that you can do these. 5 6s, 30, add 1, 31. So we're going with 5x and 6 along one of them, and x and 1 along the other one, and they're both negative. Number 39. 12x squared minus 23x plus 10. Okay, both composite numbers, so this could be a real mess, but they must never split both of them, but they could. So we have an awful lot of trial and error. 12 multiplied by 2, 24. So it's definitely going to be split. It's not going to be 6 and 2 because this is odd, so there has to be an odd component and an even component. And there has to be an even component and an odd component, because you've got to have one odd plus an even to make odd. So the oddness is helping me here. That's 15 and 8, I have it. So there was a lot of number theory went into that. Because that was odd, I needed two odds opposite each other. Okay, now they're both minus. So you can double check here. Did you get 8x and 15x is 23x, negative, 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 negative. Great. That's real higher level maths now, what you just saw there. Okay, that's where it's at. 9x squared minus x minus 10. When we do our cross products, there'll be 1 between them. Two composite numbers, so there's lots can be happening here. But it's odd too, so I'm definitely splitting odd odd. And then because of the symmetry here, it has to be 5 and 2 probably. 6 and 15, no way. And swapping them won't work either. Oh dear. Let's do like if I did 3x 5 and 2, it's way too big. How can I only get a difference of 1? I'm challenged. Yeah, it must be 9 and x and oh look, 10 take away 9. Hold on, let's do it again. I forgot. 9x squared minus x minus 10. It is an example of the difference. 10 take away 9 is 1. So what it means is it's not splitting them at all. Okay, it's going like this. And we've 10x and 9x. And then which one wants to be negative? So basically, if I can write down another one there, I can go 11x squared and put 3 here. 11 take away 3 is negative 8. And I could put plus or minus x here, as long as this one is negative. So then I know for sure it's going to be 11x and 3 together. It's going to be x and 1 together. And I can figure out it's 3x and 11x, and this one needs to be negative. So all I'm doing up here is going which one needs to be negative. This one needs to be negative. There's a negative here and a positive here. And that's the answer, 9x minus 10 by x plus 1. So I'd nearly forgotten my own method there, but it was just a kind of knowing that you won't split composites, and knowing when not to split them is very valuable. Okay. Odd. So it could be 4 and 1, or it could be 2 and 2. 36 can be 9 4s, 4 9s. It can be 6 6s. It can be 2 18s. It's a lot going on here, but we're getting 7 by the time. So I'm finding this hard. Let's go with 9x and 4x and see how we go. And if that doesn't work, let's go with 6x and 6x, which isn't going to work. Let's come back up to this. We could put 4 here and we'd have 16, and 1 here and we'd have 9, and we have it. Now I'm only worried about this. We have it because it's 16x take away 9x. So I can put my 16x and my 9x. And you say, how do I end up with minus 7x? That has to be minus. If that has to be minus, that has to be minus. Wow. Okay, so 9x minus 4. So you can see there's some method here, but it's I'm trying to teach you an awful lot. This one lesson, and it's a half an hour of a lesson. This one lesson it's like 3 or 4 weeks worth of learning. So use pause a lot. If you don't get it first time, leave it and come back to it. And the good news is, in the Leaving Junior Cert now, the questions are nearly always with an x squared. They're always very easy. Okay, so as always, we'll see you in the next one.